skipping questions, yeah. There's pages, questions that we're going to skip. Quite a few. All right, so 12.3 is homework 24. This homework is due on Monday. Homework 23 is due tomorrow. Okay. So go ahead and copy down. This is the geometric general rule. What page is that on? So I can. Page 7. So everybody go to page 7. And I'll give you a moment to copy this down. All right, so this is a geometric general rule. And yes, there's quite a few things that we're not going to cover because this is not the right packet. So the actual packet is a lot shorter. So go ahead, take a moment, copy down the geometric general rule. Notice that they both need T1. So it doesn't matter if it's arithmetic or geometric. You need to know the first term. The R value is what I'm multiplying by. Because arithmetic is addition, but geometric means we're multiplying to get to the next number. So not adding to get to the next number, multiplying to get to the next number. Let me stand over here so I can see y'all faces. Beautiful faces. Make sure they're not closed. Back there, I'm not sure. All right. Now, if you can't figure out what we're multiplying by, because sometimes that's a little harder. If you can't figure it out, to figure out or to determine what your R value is, just take the second term and divide that by the first term. And it doesn't have to be the second divided by the first. It could be the third over the second. Basically, divide a term by the one in front of it. Okay? But the most basic way would be take the second number and divide it by the first. So how do you show repeated multiplication with an exponent? So that's why a geometric sequence has an exponent, because that's how you show repeated multiplication. So for arithmetic, it's a linear graph. Geometric is exponential. Questions? All right, let's hit it. I think I skipped the first one. Let's go to the second one. So looking at this is a geometric sequence because it tells me that it is. If it didn't tell you, I mean, if you look at the difference between the terms, if it's not the same, then 99% of the time it's geometric. How he looking that way when I'm over here? Oh, okay. Why are you looking that way? I need everybody looking this way because this is where the board is. So we all look in this direction. Okay. What is my common ratio? If you can't figure it out, take the second number and divide it by the first. But what number do you think we're multiplying by? By 4. That is my common ratio. We don't call it a common difference. Common difference is arithmetic. Geometric, we call it a common ratio. All right. So if I'm multiplying by 4, let's pick up our calculators and keep multiplying by 4. So what is 8 times 4? 32. Now take 32 times 4. Wait, what is it? 128. Now take 128 times 4. 512. And then take 512 divided by 4. I mean, not divided, multiplied by 4. 2048. So let's write our rule. In order to write a geometric rule, T sub n equals the first number. And in this example, the first number is 0.5. And then I personally always put my common ratio in parentheses. Now, that's not required. You don't have to. You could just put the little multiplication sign in between, but I like to put it in parentheses. Now that you have your rule, use that rule to figure out T14. And it is going to be a big number because we're multiplying by 4. It's a big, big number. Anybody need a calculator? Okay, let me go ahead and type it in. Okay. 33,554,432. It's a lot of money. Any questions? All right, let's go to the next page. Look at number 3. Okay. So going to the next page. Again, it is geometric. Now the numbers are getting smaller though. So what that tells me is that I'm multiplying by something less than 1. And you can write that as a fraction or a decimal. If you can't figure out what you're multiplying by, again, R will be the second number divided by the first number. So you can write it as 1/4 or 0.25. Now I will probably always use a fraction, but no. All right, so now that we know we're multiplying by 1/4, go ahead and find the next 4 numbers. All right, go ahead and write your rule. And when you write your rule, you always start off with the first term. So arithmetic and geometric start off with the first term. So that's 1,024. And again, I'm going to write mine with a fraction. You can write yours with a decimal. And now use that rule to find the 14th term. It's going to be a really small number. And because it's so small, some of your calculators may put it in scientific notation. Oh, wait, 152. Oh, I missed a number. Hold on. Okay. Any questions? Gotta write all my answers so that I don't have to keep typing it in. 152. Okay. Go ahead and do question number, oh, no, we're gonna do 3 together. Let's do 3. Or, yeah, 3. So looking at this rule, what is the common ratio? The common ratio would be what? Is it going to be -2 or is it 5/4? It's always the base of the exponent. Yes, it is. So my common ratio is positive 5/4. My T1 is -2. So let's go ahead and list our 4 terms. Take that -2, keep multiplying it by 5/4. And that would be my 5 numbers. Questions? So far, so good. Nothing complicated. All together for the quiz next week, you're going to have 5 formulas that you'll need to memorize. So far we have those first 3. All right, let's see. Where are we going next? Okay, let's look at number 4. All right, number 4. Is this arithmetic or geometric? Are we multiplying or are we adding? What do you think? Because on the test, it won't say it. So you'll have to figure out what are we doing? Are we adding or multiplying? Who says adding? Who thinks multiplying? It is multiplying. So that means this is geometric. And because it's geometric, we do not have a common difference. We have a common ratio. Now, notice how my signs are going back and forth. That tells me I'm multiplying by a negative number. So, take the -40 divided by positive 160. Again, you can write that as a fraction or as a decimal. And then go ahead and write your rule. T sub n is the first number multiplied by -1/4 or -0.25 to the power of n minus 1. Go ahead and use that rule to find your T6. Go ahead and compare your answer. I wrote it as a fraction or decimal. I don't know which way your calculator wrote it. If you use the 1/4, it may have given you a fraction, but either one of those would be correct. Okay, go ahead and do the next one by yourself. Do number 5 by yourself. Okay. So I'm gonna write it 2 different ways. So that would be, I got 3 halves, or you can say it's 1.5. This is your common ratio. This is the rule. Now I'm going to find T8. So to find T8, substitute in 8 for N. And I got negative 136.6875. Did anybody's calculator give them a fraction? No? Okay. And that's it. All right, couple more questions and then we will be done for today. Let's talk about the bouncing ball. We're skipping all the way to number 8. So skip all the way to number 8. So we got Kimmy. Kimmy's playing tennis. After one hit, the tennis ball continues to bounce until it eventually stops. The highest point of the ball is 6 feet. I don't know how it changed from a tennis ball to a basketball, but we're going to, well, maybe it did magically. It just in the air changed. I don't know. But each time the ball bounced, it rebounds to 2/3 of the previous height. This word of, anytime you're trying to find, if you see the word of, that's an indication that you're multiplying. So if I said like 2/3 of my money goes towards rent, that means I have to multiply my salary or my monthly income by 2/3. So the word of indicates multiplication. So because of that, why is this a geometric? Because we are multiplying. We're multiplying the height. By 2/3. That's why it's multiplication. All right, so we started off, this starts off at 6 feet. So that's my T1. So my rule would be T sub n equals T1 and then my common ratio, 2/3, to the power of n minus 1. Okay, so here's where people get confused. I'm going to go ahead and draw my diagram because, you know, it says, what is the height of the ball after it hits the 5th time? That means I'm looking for T6. But let me go ahead and draw a diagram. So I start off at 6. This is my initial height. So it's going to rebound. It's going to hit the ground, rebound up, hit the ground, rebound up, hit the ground, rebound up. Every time it does, it's lower and lower. So this is the first time it hits. This is the second time it hits. This is the third time it hits. This is the fourth time it hits. This is the fifth time. So after the height, if this is my T1, this is T1, that means that this height would be T2, then this height would be T3, this height is T4, this height T5, this height is T6. So you're substituting in a 6 for part C. This is a test question, the bouncing ball. It's on every test, and I believe it's on the final. So I'm going to find T6. The biggest mistake, half of y'all going to plug in a 5. You're going to miss it because you're not listening. It's 6 because it's after the 5th height. This is my little diagram. Start off at 6 feet, hits the ground, and the next height is T2. This is T2. Then it hits the ground. This height would be T3. This height is T4, okay? So after means T6. So when you type that in your calculator, you get 6 times 2/3 to the power of. All right, as a fraction, do yours give it to you as a fraction? All right, so as a fraction, you would say 64 over 81 feet. But as a decimal, and I don't care which way you write it, it would be approximately 0.8 feet. That's what that would be. All right, go ahead and do the next question by yourself. That's 3/4. Oh, is that a 3/4? Oh, okay. And that should be n minus 1. Nope, it's after, not after. After. All right, here are my answers. So again, it's T5. T5 because of the word what? After. All right, so I do want you to copy down the next formula, even though we're done. I want you to copy it down so that we have it, and tomorrow we can just go right to it. So copy down. This is the formula for geometric sum. Can somebody tell me what page this is? 11. Okay. Go ahead and copy this formula down. Now notice that for a geometric sum, we don't need to know the last term. For arithmetic, I need to know the first and the last. But for a geometric, I just need to know the first, what I'm multiplying, and how many terms we're adding all together.